8412. What corrective action can a pilot take to prevent a retreating blade stall at its onset? A. Reduce collective pitch and increase rotor RPM. B. Increase collective pitch and increase rotor RPM. C. Reduce collective pitch and decrease rotor RPM. The correct answer is A. The pilot should decrease collective pitch, increase rotor RPM, decrease forward airspeed, and minimize maneuvering when blade stall vibration first appears. 8413, which is a major warning of approaching retreating blade stall. A. High-frequency vibration. B. Tendency to roll opposite the stalled side of the rotor. C. Pitch up of the nose. The correct answer is C. The following low-frequency vibrations and pitch up of the primary rotor system are the principal indicators of an imminent retreating blade stall: the nose of the helicopter and its propensity to roll in the direction of the side of the rotor system that is stalled, retreating blades. 8417. How does high-density altitude affect helicopter performance? A. Engine and rotor efficiency are increased. B. Engine and rotor efficiency are reduced. C. Engine efficiency is reduced, but rotor efficiency is increased. The correct answer is B. A major warning of approaching retreating blade stall is a tendency for the helicopter to roll in the direction opposite to the stalled side of the rotor. This is commonly referred to as roll/yaw couple or blade flapping roll. Retreating blade stall occurs when the retreating side of the rotor experiences a decrease in lift due to factors such as high angle of attack, high airspeed, or turbulent airflow. As a result, there is an imbalance in lift between the advancing and retreating blades, leading to a roll tendency in the opposite direction. The roll/yaw couple manifests as a roll moment that causes the helicopter to roll towards the advancing side of the rotor. This is a critical warning sign for the pilot to take immediate action to prevent further stall conditions and maintain control of the helicopter. High-frequency vibration, option A, is not directly associated with retreating blade stall, but can indicate other issues such as imbalances, mechanical problems, or dynamic instability in the rotor system. Pitch up of the nose, option C, is not a specific warning sign of approaching retreating blade stall. While the aircraft's pitch attitude may change due to various factors, it is not directly linked to the approaching stall condition. Therefore, the major warning of approaching retreating blade stall is a tendency to roll opposite the stalled side of the rotor. 8418. How is helicopter climb performance most adversely affected? A. Higher than standard temperature and high relative humidity. B. Lower than standard temperature and high relative humidity. C. Higher than standard temperature and low relative humidity. The correct answer is A. Helicopter climb performance is most adversely affected by higher than standard temperature and high relative humidity. Both temperature and humidity affect air density, which plays a crucial role in generating lift for the helicopter. Here's how these factors impact climb performance. Higher than standard temperature. As the temperature increases, the air density decreases. Warmer air is less dense, meaning there are fewer air molecules available for the rotor blades to generate lift. With reduced air density, the rotor blades have to work harder to produce sufficient lift, resulting in decreased climb performance. High relative humidity. High humidity indicates a high moisture content in the air. Moisture in the air affects its density and reduces the available oxygen for combustion in the engine. With less oxygen available, the engine's power output decreases, leading to reduced climb performance. When both higher than standard temperature and high relative humidity are present, they compound the negative effects on air density and engine power. The combination of reduced air density and decreased engine power adversely affects the helicopter's climb performance, making it more challenging to climb efficiently and maintain higher altitudes. Therefore, higher than standard temperature and high relative humidity have the most adverse impact on helicopter climb performance. 8420. What causes Coriolis effect? A. Differential thrust of rotor blades. B. Changing angle of attack of blades during rotation. C. Shift in center of mass of flapping blade. The correct answer is C. The Coriolis effect in helicopter rotor systems is caused by the shift in the center of mass of the flapping blade. The center of mass refers to the point within the blade where the mass is evenly distributed. During rotation, as the blade flaps up and down, the center of mass of the blade moves in response to the changing lift forces acting on it. This shift in the center of mass creates a gyroscopic effect known as the Coriolis effect. The Coriolis effect introduces a couple or a twisting force on the rotor hub, causing it to tilt in a direction opposite to the blade's motion. This effect is a result of the conservation of angular momentum. It's important for pilots to be aware of the Coriolis effect, as it can impact control inputs and stability during flight. Proper understanding and compensation for the Coriolis effect are essential for safe and precise helicopter operations. Therefore, the Coriolis effect is caused by the shift in the center of mass of the flapping blade in a helicopter rotor system.